this quadratic, which is the graph y equals x squared minus 4. And then we'll take a look at, it's very hard to see here, but it's very, very faint. We can see it though. The reciprocal function, 1 over x squared minus 4, which actually in this case has 3 branches. There's one here on the left, one here on the right, and then one right here in the middle. Okay. Alright, so let's fill out this, this table again for the quadratic function first, and then we'll do the same thing for the reciprocal function and see what features we have in common here. Okay, so first of all, for the quadratic function, we want to look at any zeros or vertical asymptotes. Well, we see with this quadratic there are no vertical asymptotes, but there are 2 zeros, one at -2 and one at +2. So we can say here x equals positive or -2. The interval or intervals on which the graph is above the x-axis. Well, the graph is above the x-axis over on this side here, where x is less than -2, and on this side where x is greater than 2. And of course then we're also going to be looking at where the graph is below the x-axis, and is below the x-axis between those 2 spots, between -2 and 2. Okay, so we can fill out those 2 cells in the table now. So the interval in which the graph is above the x-axis, well, this occurs when x is less than -2 and when x is greater than 2, and the graph is below the x-axis when -2 is less than x is less than 2. The interval or intervals on which the function is increasing. Well, as we go from left to right, we see that here the graph is decreasing down to the vertex, and then it starts increasing from the vertex over to the right hand part of the quadratic, so that the increasing begins here at x equals 0 and continues on to infinity, and decreasing would go from -infinity to 0. So in terms of x values, the interval of x values where the function is increasing is from 0 to infinity, and is decreasing from -infinity along x values from -infinity to 0. And then we want to see which point where the graph is, the y value is 1. Well, take a look here. The y value is 1. If you take a look, move along here until it hits the quadratic, it's 1 right there. Now we could guess to see where what x value that gives us here, and it's also, there's another part where it's equal to 1 over here. Now like I said, we could estimate, but I prefer not to do that. So what I'm going to do here is I'm going to say over here y equals 1. That's what we're trying to find out. So y equals x squared minus 4. I'll add 4 to both sides, so we've got 5 equals x squared. I'll take the square root of both sides. So we've got the square root, and it's then plus or minus root 5. So therefore x, if I can just do a little bit of mental math here, the square root of 5 is about 2.24-ish, rounding to the nearest hundredth. Okay, so that would be the x value. So the points would be positive 2.24 and 1, or positive root 5 and 1. And the other point would be negative 2.24 and 1, or negative root 5 and 1. Now, because I do like exact values, I think we'll just leave it with the root 5. Now, we're also going to have to do see where the y value is -1. So let's just substitute that in right now, and so this is, we're substituting the value of y in for y of the quadratic. We'll add 4 to both sides. We're going to get 3 equals x squared. Take the square root of both sides, we get x equals plus or minus square root of 3. And just to locate that, see we got negative 1 here. The graph crosses the y equals negative 1 right here. And again here. So just so you get an idea of where that would be graphically, it would be positive or negative 1.73. But I will be sticking with the exact values of root 3 and root 5 for those two. So the pointer points where the y value is 1, positive or negative root 5 and 1, and where the y value is negative 1, positive or negative root 3 and 1. Now one other thing I'm going to just add in here, just because I think it'll be important to note, is the y-intercept. The y-intercept is where y equals negative 4. Okay? And then we're going to, of course, take a look at the y-intercept for the reciprocal function in a few moments. Okay, so now that we have all that information for the quadratic, we're going to do the same thing for the reciprocal function. Now, of course, it's that very faint line here, those 3 branches. And so we'll take a look at the zeros, or vertical asymptotes, for this reciprocal function. And we see that this function, this graph, here does not cross the x-axis, here does not cross the x-axis, and here it does not cross the x-axis either. So there are no x-intercepts, but there are 1 and 2 vertical asymptotes, and those occur at x equals 2 and x equals negative 2. So the vertical asymptotes, actually sorry, I should have put this here also. Vertical asymptote is x equals 0 for that reciprocal function of the first graph we looked at, or the first set of graphs, and the vertical asymptote in this case is x equals plus or minus 2. So if I didn't write it as a vertical asymptote, we would get confused to say, oh, there's zeros there and zeros here, but they're not zeros for the reciprocal function, but just rather for the original function itself. Okay, so now we'll take a look at when the intervals on where the graph is above the x-axis, and we'll also look at where the graph is below the x-axis at the same time. So the graph here is above the x-axis when the graph is, or when x is less than negative 2, and it's also above the x-axis when x is greater than positive 2, and the graph here is below the x-axis when x is between negative 2 and 2. Okay, so we can fill that part out on the table. So it's x less than negative 2 and x greater than 2. Looks familiar. And then from negative 2 less than x less than 2. We could write this in interval notation also, but I just started in set notation there, or a partial set notation, so I'll just keep that going. Looking at where the graph is increasing, well, the graph, as we go from left to right, the graph here is increasing from negative infinity to negative 2, and it's increasing from negative 2 up to 0. Those are the x values, of course, and the x values where the graph is decreasing from 0 to 2, that's decreasing, and it's decreasing as you go from left to right on the x values, the intervals of the x values, from 2 to positive infinity. So the graph is increasing